Okay, this video is going to be about differentiability and continuity from chapter 2.1. So, a function can be classified as differentiable on the closed interval AB if the left limit is equal to the right limit, and also if the function is differentiable on the open interval AB. So that's the definition of differentiable on a closed interval. These are some properties regarding differentiability and continuity. So if f of x is differentiable, if the function of f of x is differentiable, then that function must also be continuous. But if the function f of x is continuous, that doesn't have to mean that it's also differentiable. So here are a couple reasons why a function would not be differentiable. One of the reasons why a function would not be differentiable is if it's not continuous. Obviously, if it's not continuous, if for example if it has an asymptote, or if there's the limits aren't equal to each other, then that would be continuous. Also, if there's sharp turns or vertical tangents, those would also be reasons why a function would not be differentiable. So this is an example. This is one of the examples of how or why a function would not be differentiable. So for this example, we are given our function f of x equals x squared times x minus 1 over x minus 1. And right away we can see that this will cancel, leaving us with a whole, shown right here at x equals 1. So obviously this means it's not continuous. So because it's not continuous, the function is not differentiable. Okay, for this one, it's absolute value, and so f of x equals absolute value of x plus 3, and it's drawn on the graph right here. So with absolute value, you need to split it up into a piecewise function. So from the right, x plus 3, where x is greater than or equal to negative 3, and we also have negative x plus 3, where x is less than negative 3. So we want to find the limit coming from the right. So we're going to start with the limit as x approaches negative 3 from the right. And we start with our definition, f of x minus f of negative 3 over x minus negative 3. So limit as x approaches negative 3 from the right is x plus 3 minus 0, just substitute it in, over, this is x plus 3, and x plus 3 over x plus 3 is just equal to 1. So that's 1 is the limit coming from the right. So for the limit coming from the left, it's the limit as x approaches negative 3 from the left. So we have f of x minus f of negative 3 over x minus negative 3. So the limit as x approaches negative 3 from the left is negative x plus 3 minus 0 over x plus 3. And this is equal to negative 1. So obviously 1 does not equal negative 1. So the limit as x approaches negative 3 from the right, f of x, does not equal the limit as x approaches negative 3 from the left, f of x. Therefore, it's not differentiable. Okay, for our last example, we have the function f of x equals the fifth root of x. So, start off with the limit. The limit as x goes to 0, f of x minus f of 0 over x minus 0. So you just plug it in. So then the limit as x goes to 0, we can write this as x to the 1/5 by just moving this out to the exponent. So x to the 1/5, let me rewrite that. X to the 1/5 minus 0 over x minus 0. And we can simplify this limit as x goes to 0, 1 over x to the 4/5. And this is equal to limit as x goes to 0, x to the negative 4/5 by moving this to the numerator. And this would equal the limit as x goes to 0 of 1 over x to the 1/5 to the 4th. Oops, sorry about that. So, and this would just equal infinity. Thank you for watching this video.